Alright guys, let's look at Unit 10, Lesson 1, which is moles and molar mass. For mass, stoichiometry is the study of the amounts of reactants and products in chemical equations. So it's kind of like the study of the recipes. So let's review how we count atoms, because you're going to need to know this for the first lesson. So the subscripts are the number of atoms in a formula, and the coefficients are the total number of molecules or compounds. So let's look at this. For example, if I were to look at this and ask you how many CAs, Ps, and Os, there's 9 CAs because 3 times 3 is 9. There are 3 Ps times 2 Ps, that's where we get 6. And there is 4 times 2 is 8, times 3 is 24 oxygens. So now let's look. How many oxygen atoms are in each? So pause and see if you can remember how to do this. Great, well, welcome back. Now let's look. So let's look at NH4NO3. How many oxygens are in that molecule? There's 3. 3 O's. In C8H8O4, how many oxygen atoms are there? There's 4. In O3, ozone, how many oxygen atoms are there? There's 3. And in this equation, C3H5NO33, there are 9. So now let's talk about the mole. The mole is a unit that measures the amount or the number of particles of a substance. 1 mole is going to be equal to 6.02 times 10 to the 23rd particles or things. And 1 mole is going to be equal to the formula mass. So what do you call moles of avocados? Guacamole. Silly joke, you know me. Why do we use it? We need to understand that atoms are so tiny that we have a lot of them in any given sample. So when we're looking at something that has a lot of things, like a dozen eggs, we know that there's 12 eggs. Well, 1 mole of eggs is 6.02 times 10 to the 23rd eggs. If we were to have 3.5 dozen roses and I wanted to know how many roses you would have, you would say you would take 3.5 times 12 and you would have a total of 42 roses. The way that we can get to moles is we have to look at the molar mass, or we're going to call that the gram formula mass or molecular mass. This is the mass of the formula expressed in grams. It's equal to 1 mole and it has units of grams per mole. The element's molar masses are reported on the periodic table. So when you look at your periodic table, all of those masses that are up there are actually molar masses. That's the mass of 1 mole of the element on the periodic table. So how do we calculate molar masses, or gram formula mass, which we're going to abbreviate GFM? First, you count the atoms in the compound. Then you look up the mass of each element on the periodic table. You multiply the mass by the number of atoms of each element, and then you add up the total. So let's look at some examples. What is the molar mass of iron? Here's a snippet from your periodic table. The molar mass of iron is 55.847 grams per mole. What is the molar mass of copper? Okay, copper is Cu, so it's 63.546. Now you can round these values, but when you round them, you can round them to 1 decimal place. So let's look, what about for compounds? What's the molar mass of water? Well, what does water look like? Water looks like H2O. So what we have to do is we're going to have to, since we're talking about a compound, we're going to have to figure out what the mass of each element is and then add them up. So let's start off with hydrogen. We have 2 hydrogens. Each has a molar mass of 1.01. I got that off the periodic table. We have 1 oxygen, okay, with a mass of 16. So when we do 2 times 1.01 plus 16, we get 18.0 grams. Okay, grams per mole. That's the molar mass of water, 18.0 grams per mole. What is the molar mass of calcium chloride? Well, the first thing is, what does calcium chloride look like? Looks like CaCl2. So how do we do that? Again, what is the mass of calcium? It's 40.1 off the periodic table, rounded to 1 decimal place. There are 2 chlorines, so we're going to have to take the mass of 1 chlorine off the periodic table, which is 35.5, and multiply that by 2. Then we add them all up, and we get 111.1 grams per mole. How about a practice? What is the molar mass of calcium? Pause the video and come back to it. All right, well, calcium is an element, so the molar mass is going to be equal to whatever mass is on the periodic table. So the molar mass, the mass off the periodic table is 40.1, so the molar mass is going to be 40.1 grams per mole. What about for bromine, Br2? Pause the video, answer this on your own. Welcome back. Well, we're looking at Br2. Bromine is off the periodic table, but we have two of them because of our formula. Br2 says that we have two. So we have to take 2 times the mass of bromine off the periodic table. And that will give us a total of 159.8 grams per mole. And this is the molar mass of bromine. What about the molar mass of CO2? Okay, practice this and come back to it. Welcome back. So now we have CO2, okay? How many carbons do we have? We have 1, so it's just going to be the mass right off the periodic table. We have 2 oxygens, so we're going to take 2 times the mass of oxygen rounded to 1 decimal place off the periodic table. Then we're going to add them together and get 44.0 grams per mole. Now check your understanding. We're going to go over this in class tomorrow, but I want you to try it tonight.